Okay, question 4B. We've got two oxidation half reactions and the cell potentials next door to them. Now, when written like this, and this is why I like to use the subscript to show the difference. I mean, I would like to see the E being clarified as either E for oxidation or E for reduction. So that we're sure which one's which. However, it is reasonable to assume that if the reaction is shown as an oxidation half reaction with an E value next to it, in the absence of E red, then you must assume E ox. And so in this case here, if I was to write it out again for the first one, you got Z producing Z ions and an electron. This is an oxidation half reaction, and written here, I would have preferred to say E oxidation is equal to 0.30 volts. You might be thinking, well, Les, didn't you write this? Why didn't you put ox on it? Well, because this isn't a standard convention or anything. I mean, I just made this up. So you're not going to see it in an exam. But if you were to see this in an exam, an oxidation half reaction with an E next to it, then you must assume that this is the oxidation potential. Now, it is reasonable then, I think, to convert this into a reduction potential, because you can see the patterns on your from your periodic table much more clearly if these are expressed in reduction potentials. So let me just reverse this around, and I'm going to put my Z ion and an electron to produce a Z metal, and my E reduction, as it would be expressed in your data book, is the same numeric value but the opposite sign. So it's going to be negative 0.30 volts. I'm going to do the same with the other one. It's the X ion and an electron producing the X solid, and my E for this reduction potential then is going to be negative 0.40 volts. Now, when you're looking at the trends in your data book, you'll see that as you're going down the table, the negative values are increasing. Well, that is, the value is actually decreasing. The negative 0.30, negative 0.40, negative 0.50, negative 6, and negative 1 point, negative 2.0, whatever. You know, the point is that the magnitude of these negative numbers get bigger as you go down the page. So, if that's the case, then these two half reactions are written in order. The Z half reaction would actually be written before the X. So the Z is the stronger oxidizing agent, the X is the stronger reducing agent. Now, the question is asking for the E net, which is equal to my E reduction half reaction at the cathode minus E reduction half reaction potential at the anode. Now, at the cathode, this is where reduction occurs. That's the oxidizing agent. The Z plus is the oxidizing agent here, and so it's going to be negative 0.30 volts. And minus my reduction potential for the anode, which is the negative 0.40 volts. And then this becomes negative 0.3 volts plus 0.4 volts becomes positive 0.10 volts.